Hey guys, welcome to your notes for today. Today we're going to be talking about scatter plots and data analysis. So something I want to refresh your memory on before we dive too much into it is positive and negative slope, because that is part of what we'll be talking about today. So just a reminder that our positive slope is always going to give us a line that looks like this. That is our positive slope. This is our negative slope. And we'll use this in our analysis of scatter plots later. Let's take a look at what one of these problems would kind of look like. So, I'm going to skip that problem. So first of all, what is a scatter plot? Well, a data with two variables or pairs of numerical observations is called bivariate data because we have two variables. A scatter plot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. For example, bivariate data set year and number of visitors can be displayed as a scatter plot. And we'll look at what these scatter plots kind of look like, but there's different kinds like this. And they're just dots. You don't really put a line through them unless it's a line of best fit, which we'll talk about later this week. So let's look at this first problem. It says construct a scatter plot of the number of viewers who watch the new seasons of a certain TV show. Let the horizontal axis or x-axis represent the number of seasons. Let the vertical axis or y-axis represent the number of viewers. Then graph the ordered pairs, seasons, comma, viewers. So it gives us seasons, comma, viewers because this is our x, this is our y. So we see it, we have seasons on our X, viewers on our Y, and millions. And on data like this, where I have like 31.7, and I see that it's counting by fours, I'm not too concerned about the exact point where you put this dot. It just needs to be close to where that point would be. So I see 32 is here, 31.7 is a little less than 32, so I'd probably put a dot right there for season 1. So on and so forth. I would continue doing that. So you see this is right where I was pointing with my cursor. And keep doing that. And then we can see a trend. And that's what we really want to see with scatter plots. We can see that it has a trend of a negative slope. And we call that association. And we'll talk about different types of associations here in a second. But first I just want to, just for a quick little practice, I have this practice problem right here. Construct a scatter plot with the weight of an alligator at various times after hatching. So I have it here on the side so that we can actually do it. So let's take a look at what this looks like. Construct a scatter plot with the weight of alligator versus times after hatching. So first you have to determine what's going to be on your X and what's going to be on your Y. Well, I like to have time, generally all the time, on our x-axis. So weeks is going to be on our x-axis, while weight in pounds is going to be on our y here. Weight in pounds, or lbs. So at 0 weeks, we're at 6 pounds. At 9 weeks, so a little bit less than 10, we're at 8.6 pounds. Again, this just needs to be relatively close to where the point would be. I'm not looking for exact. Now, if the weight is 10, then you should be, yes, on that 10 line. But 18, that's in between 15 and 20, so I know it'll be about right there. But if instead of right there, if you accidentally put your point right here, yeah, I will still be able to see the trend. 13.6, so that's going to be right here. Oh, wait, sorry. I was looking at the wrong point. 27, and we're at 13.6. So 27, we're at 13.6. Probably going to be somewhere right there. At 34, we're at 15. So right between 14 and 16. We're at 34. So about right here. 43, we're at 17.2. 43, 17.2. Probably going to be close in between. 49, we're at 19.8. So we're right there, close to the top. And we can see this trend of an alligator at various times as they're hatching. And it makes sense that an alligator is going to get bigger, and it's not going to be consistent. It's not going to be a constant rate of change, but it's still going to go up in a relatively close to a line. And that gets us to our types of variation. We have a few different types of variation, of association. Types of variable association. We have 3 types. So these are the types I want you to write down, memorize, know. Positive association, where we see this positive slope. As x increases, our y increases. This is positive association. Then we have negative association on a negative slope. As x increases, y decreases. It's going down, so it's negative. And no association. There's no real association here. So the two things, my x and my y, my two variables, are unrelated because it's just a random assortment of points. So there's no association. These are the types of variable associations. We also have types of linear associations. Linear and nonlinear. Linear are the data points lie close to a line, close to a constant rate of change. The data points lie in a shape of a curve would be nonlinear. So for our alligator, I would say that this is a linear association. No, that's not a perfect line. I'm not saying it's a perfect line. I'm saying it's a linear association, though. They relatively are close to a line, rather than nonlinear, which is going to be some sort of curve. You also have 2 things that you need to know when you're talking about, when we're analyzing scatter plots. 2 key terms to know are clusters. So when you have multiple different points all close together, and an outlier, something way out that doesn't fit the data. So if I had one data point way down here, that would be an outlier because it doesn't go with the rest of the data. Outliers can skew data, and it's important for us to recognize them so that we can actually label them as such. or printed out. I hope you have a wonderful day. Again, send me an email if you have any questions, comments, or concerns. I will see you all later.